we're doing for MnROAD right now is different rehab methods for resurfacing older concrete pavements. And what we're building is a series of 12 different asphalt overlays, various types of lift thicknesses and material configurations to look at reflective cracking, ride improvement, and also the longevity of the different types of surfacing materials. Yesterday we built two different types of surfaces. Those are single lift types of approaches, both laid down with a spray paver, which is designed to get an exceptional tack coat bond strength between the asphalt overlay and the concrete. One of those was an ultra-thin bonded wearing course, which is kind of a gap-graded asphalt mixture, kind of like a high-performance chip seal. The second was a 12.5 millimeter super pave mix, yet it was placed with a spray paver. And the spray paver has the hopper, the tack coat bar distributor, and the laydown portion of the paving equipment all rolled into one paver. And both those were placed yesterday. Those are single lifts. Now today we're placing a 19 millimeter mix on 5 adjacent cells. And each one of these cells will have a second lift put on top, totaling 4 inches after the second lift is placed. And in these we're looking at different aggregate, nominal max aggregate sizes. And we're also looking at different approaches to mixture design. One of them is the Super Pave so-called 95-5 mixture, where we design in the lab for 5% voids, and we try to compact to 5% voids in the field to try to bring the mixed design and field component together. Another one is we're doing a regressed 3% air voids, where we design for 4% and then back in a 3% air voids by adjusting the asphalt content to get us there. For density, we're using several different approaches. The paving equipment has intelligent compaction feedback built into it, and we're monitoring that. It also has an infrared thermal bar mounted on the back of the paver to detect the thermal segregation or consistency of the mixed temperature as it's being placed and compacted. We're also using GPR equipment for full coverage, GPR measurements. It's called the rolling density meter, and through that we get the surface dielectric, which can be related back to air voids and density in the mixture. And finally, we're kind of taking the tried and true approach using calibrated nuclear density and bulk-specific gravity cores to form sort of the foundation for this comparison in different density approaches.